Double bounced. There we go. Alrighty, friends. So if I could just have everybody's attention for a little bit, we can close our laptops for first part of class. We're going to open them back up and start doing web work in a bit. But it'd be nice to have everybody with me to begin with, unless you're taking notes, then that's a whole different thing. So exam 1 is in about 2 weeks. Like right now, let's just say 2 weeks from today. If we need more time, we'll push it back. I'll tell you what I'm not going to do is move it forward. Okay, so like that's the soonest it will be. I'm never like going to like shorten your amount of time to prepare. I do really great review guides, so I'll give you tons of materials to review with, tons of practice problems. Maybe by like Friday of this week. This is classic for my exams, no calculators, an 8.5 by 11 double-sided note sheet with whatever you want. I think it says note sheet, not a knot sheet, so that's good. And then integral derivative table of your choice. I gave you a swell one, but you can use whatever ones you want or whatever portion of that you want, and you can put whatever you want on all this stuff. There will be a new web work opening in about 20 minutes, but I wanted to talk about some stuff first that's going to help you rock that web work out. So before we do that, yeah, like I said, I got like 3, 4 things I want to show you before we start. Is there any questions about any of this? Yeah. Okay. Outstanding. Outstanding. Wonderful, wonderful. How's the lighting in the back? Are we okay back there? Need more light? Happy to give you more light. Pretty good? Oh, that's nice over there. That's beautiful. Okay, you tell me. You would tell me if you needed otherwise. So, let's take a look at a few examples. First off, let's say I had this integral. Someone asked me about this last time. I can't quite remember who asked me, and maybe it was even Friday, like, what happens, what happens if both things repeat? So here, coming into this, I've got an integral of e to the x times cosine of 2x. Think about how those derivatives roll. The e to the x never gets simpler. The cosine bounces between sine and cosine. Sine changes in front, but neither of these things get simpler. So let's just first note that there's multiplication. So I'm thinking parts, but neither part gets simpler. So in the end, we can find a formula to do this, but I want to show you, you have to see this once, and everybody in Calc 2's got to see how to do this game. So let's just do it together once. I'm going to call this I. That's the thing I want to find, that integral. And you'll see why I'm labeling it in a minute. Like normally we wouldn't do this, but here it's going to pay off. So we're going to use parts. And it doesn't matter what we do for our parts. Let's let u be e to the x. And so dv is cos 2x dx. And du is e to the x dx. And v, remember those nice rules that I gave you last time? So there's this one, the sine version, and the e version. So happy to have those at my side, because then I can just rock that out. So let's keep track of what's going on here. I is equal to u times v. So that's the uv part, right there. And then minus integral v du. So minus the half is going to come out in front, integral, and check this out. I'm going to change the order. I'm putting the sign first. You know, when you think, or excuse me, I'm putting the e first. This is just v du right here. Integral v du. And let me stop. How does that seem? Is there any questions on this? It's been a weekend. You didn't have any like calc to do over the weekend, so let's make sure we're all rolling. All right. So look at what I've got again. Oh my God, another thing that looks a lot like the original. Nothing's got better. So I'm going to try parts again. At this point, you might give up unless you saw what was maybe coming around the corner. So let's do parts again on this integral. This one right here. So I'm going to let you, I'm going to be consistent with what I picked for you. I'm going to let u be the e to the x again. Du is e to the x dx. I'm going to let dv be the sine of 2x. And then I remember that this is negative 1 over k cos kx plus c, you know, all that stuff. So then this is negative 1/2 cos 2x. And so now let's be real careful because this is my u dv. This is what I'm given, and it's times a negative 1/2. So let's keep track of everything. So I equals this minus 1/2. Now inside here, I'm going to do the new uv minus integral v du using this stuff right here. So it's going to be u times v, so another negative 1/2 cosine of 2x e to the x as well. Bless you. So that's this times that, written a little sloppily. And then minus integral, and this one I'll be real kind of careful with so you see the sign changes. And so then that's going to be v, so negative, bless you, negative 1/2 cos 2x e to the x dx, and close that off. So just make sure that this is kind of making sense to you before I go any further. I'll take a little nap here. Is this looking good? Any questions on any of that? So let's simplify. So I is equal to 1/2 e to the x sine of 2x, and then we're going to simplify here. It's plus 1/4 e to the x cosine of 2x. Now check out what's going on here. Look at all the net effects. So I've got negative, negative, negative. That's going to become a negative. I've got 3 negatives in a row. And then I've got a quarter from the 1/2 and the 1/2. And then this is integral e to the x cosine of 2x. I'm just switching the order on these. Notice anything cool? Anything familiar? Any old friends appear here? Yeah, Sophie.
The positive 1/4 and the negative 1/4 can cancel.
Well,
oh no, sorry, because that's because there's an integral there.
I'm glad you caught that.
Just kidding.
That is correct. That is good. It's a good math joke. You warm up with one. I like it. Anything else look familiar?
That's the original one we're looking for.
Check it out. Right here is the actual original integral. So it like appeared within this process. So I'm labeling it as I because watch this. This is a very strange move, but it's a really neat move. So I, the original integral, is 1/2 e to the x sine of 2x plus 1/4 e to the x cos 2x minus 1/4 I. So we've got the original integral expressed in terms of some other stuff and then a multiple of the original. I'm going to solve for I, so I'm going to literally add 1/4 I to each side. So just add 1/4 I over here, you get 5/4 I equals this stuff. So see, I just added that to both sides, multiply by 4/5, and I know what I is. So now I'm just going to multiply by 4/5 on each side. So I do that, 4/5 times this stuff. Let's bring it down inside here. So I, the original integral, is 4/10 e to the x sine of 2x. And then notice the 4's will cancel here, plus 1/5 e to the x cosine of 2x, and then plus c. And that's the kind of thing you just got to see once. to know that it can be done. And it's kind of cool that multiple of that I don't know, it's just cool that it works out. It's amazing. So, let's talk about another way to do it. Does anybody have that table accessible? I don't want to have to log in. Does anyone have access to World Class really quick? Or that table maybe like saved?
The reference sheet?
Yeah. Could I take a look at it real quick, please?
Yeah.
Thank you so much. Very helpful.
It's all
Oh, so nice. Thank you so much. This is great. So, and then I'll get this back to Sophie real quick. There is actually a formula for this, and they derive it by doing the process we just did. If you were to see a problem like this on web work, you might want to use the formula. That's all I'm saying. I just wanted you to see that. So let me find the formula, and I'll even tell you what reference it is. All right, so I'm going to copy this, Sophie, and I'm going to hand this right back to you. And maybe you can even help me find it. Oh, here it is. Okay, so formula 99, the number 98 is also on here, which is helpful. Number 99 says this. So notice how we could actually just use that, thank you so much. We could just use that formula, or number 98, to actually just knock this thing out. Here we have u is x. For us, a is 1, because it's just e to the x, and then the b is 2. And we could get the same answer in a very similar way. Let's do it real quick. So using these things here, this integral of e to the x cos 2x dx, just using these various things, is going to be e to the x over a squared plus b squared, so that's 5, times a, which is 1, cosine of 2x, plus, and then I put in the b, it's going to be 2 sine of 2x plus c. And let's take a look at what I've got over there and see that these are the same thing. You see that 4/5, that 4/10 is just 2/5, just not simplified. So I got the same thing, just with like way less work. So I recommend when you see this thing where you've got the e to something and then some trig thing to something here, you want to use these formulas. So it's going to be formulas 98 and 99 on that master sheet that I gave you. So that'll help. Any questions on this before going? I got, like I said, maybe just one more thing to show you, actually. Good? Cool. So, last thing to show you is example. Just depends on who you are, how spicy you're feeling about math, if this is cool or fun. As you can tell, I'm jacked up about it. It's part of my responsibility to come in here jacked up about things. So let's take a look at one. Oh boy. Okay, so I come into this process not knowing what to do. First thing is, I ask myself, can I do substitution on this? And you could try substitution. What would be the only thing I could substitute, right? You don't want to do this, because that just rewrites everything in terms of u. It doesn't accomplish anything. The only other substitution I could do would be this. And then du would be 1 over 1 plus x squared dx, and I'm not seeing this stuff in there, right? You need to have all the variables appearing in there. So this tells me that substitution is not going to work. No sub. possible. So, well, let's see, we only know two methods. When you've got this inverse trig, so for inverse trig integrals, here's a trick for integral of an inverse trig, and you will see 1 to 2 of these coming up. Well, I guess one answer is to look it up in the table, and I bet you can actually find formulas for this in the table. But let me show you how they got that formula. It's much better to be able to fish than just have to buy your fish, right? Somebody said that a long time ago. We should know that in our school that we're in, all that stuff. So here's the trick. I'm gonna let you be the arctan. There's really only one thing in there. And then what is dv? It's everything else. It's just 1 dx. It's just dx. So this is kind of the weird, not intuitive at all that this would be a thing that would work. So then I go through and I find my derivative, du, this, I already did that for us. And then v becomes x. So now, this integral in the uv minus integral v du form is going to be u times v, so x arctangent of x, minus integral, check this out, x over x squared plus 1 dx. Now I got to do this. Can you take a minute and finish this up? Or try to finish this up and see what you would do? How would you finish up? You got to do that last integral. So I leave that for you for a second. Try that. See how that goes. All right, you see a fraction. So we've got some things for some rules for approaching a fraction. Bless you. Yourself. Still pondering. Okay, cool. Yeah, what is this? Yes, yeah, yep. Good thinking. Yeah, absolutely. That's cool. Tired? Yeah. We had practice this morning.
Snow shovel.
Again, wait a minute. They have you guys doing this a lot. Boy, that's some free labor, huh? Yep. Nice. So every time it snows, you're like, oh, God.
Yeah, pretty much.
Yeah. All right, just let's check in together. I don't want to spend too long on it. I've got this fraction. When you have a fraction and there's no parentheses in the denominator, there's no square roots or anything like that, you want to shoot for the log form. Let u be the whole denominator. So on this one, I'll let us do a little scratch work here. I'm going to let u equal the whole denominator. And when I do that and I find du, I see that life is pretty good, that I made a good choice because I see the pattern of the variables appearing here and here. So I know I did it. So this just tells me that dx is du over 2x. So we're going to rewrite this thing. I guess we'll just keep doing it here. Take this thing, do the substitution. This is integral x over u. Dx is du over 2x. x's cancel. Zip, 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 zip. I got 1/2 integral du over u. Yay, natural log of u, back substitute, 1/2 natural log of x squared plus 1. So this, all here, just becomes that answer over there. And I've got a really funky thing that, you know, no human would look at and guess. That's for sure. Good to go. Questions on that, friends? Again, this might occur in the table, but it's so much better to be able to do it, and it's really cool that we can actually do it. It's amazing. We're really more powerful than we've ever been. By the first exam, we're going to be super powerful. So any questions at all, anything you want to talk? And I'll come around, we can talk about it if you don't feel like asking. So, your new web work should be open. It's very small web work. I think, I can't even remember, 8 problems, super small. I would like to have this due Wednesday night, so we're going to take the rest of the class. We've got like almost an hour to work on this thing. So I'd like to ask you to use this time in class to work on that web work. Here's the trick with that web work. It's not all integration by parts. A couple of the problems are substitution, and they're just hidden in there, okay? So there's a couple substitution problems, and the rest are integration by parts. I want you to figure it out. Let's do this together, and I am here, as always, available for consultation.
This one's substitution.
So what is that function?
Oh, that's inverse.
There you go.
Got
So
it.
inverse trig.
So that would be like the same equation that we used before.
Yeah, yeah, use this, yeah, let u be the arc cos.
What do you use for -7?
I would just pull that out in front.
Put it in front of the integral?
Yeah,
Oh, okay.
yeah, yeah. So yeah, just pull the -7 out in front, do the rest, and then multiply the whole final answer by -7.
Okay.
That makes sense?
Yeah, makes sense. And then how do you plug in the values of the
I think we'll have to talk about that as a crew.
Like so.
Does that sound reasonable?
Yeah.
Yeah, we'll definitely do that.
Mhm.
Get down to there, and then we'll.
It's number like 98.
That's awesome.
It's right there.
Oh, okay. Appreciate it.
Yeah.
Like that you're doing it by hand, not the phone. So that should be 5. You actually went.
Oh, it's 5.
Yeah, yeah, exactly.
Gotcha, I did the wrong rule.
Uh-huh.
Okay, so I gotta swap some
And then
stuff.
same thing, yeah, then this one too, tweak that up, but you're doing it right on the integral, sure, or the dv to v part.
Gotcha.
Keyboard is freaking me out, that's amazing. That's cool. Sophie, down to the.
I got a little lost.
Okay,
'Cause
yeah.
I found an equation that I think would.
Mm-hmm, yeah, that's it, that's good.
Is that the one?
That's for, yeah, from your u to du, yeah, so
Mhm.
you're gonna let u be this thing.
Right, okay, yeah,
Right.
so I have to.
Yeah, I would write all that out,
So
yeah.
you would be cosine of -1.
Yeah, and then dv is the dx.
Right.
Yes.
Okay.
So let me give everybody those tips, because I'm sure everyone's, which problem is that?
That's number 2.
That's number 2.
Mm-hmm.
And number 2, and you can see I've got a bunch of stuff up here that's relevant to that, because there's a discussion to be had. Does everybody have this one, or is there anybody have inverse sine, or is it all, everybody's got inverse cos? Inverse, okay, cool. So this is an arc sine. It's an inverse sine function. And so for this one, you're gonna let u be that arc sine, or arc cos, sorry, jeez, my good lord. You're gonna let u be the arc cos of x, and dv, you wanna use parts on this one. dv is just the dx, so it's like that arctan that I did. So give that a shot. You look up that formula for the arc cosine. I mean, if you're working on another one, that's cool too. This will be recorded, and you'll probably wanna check it out. Yes. Okay.
This is correct, right? Because it's gonna be negative.
Yeah,
That's right, it's square root.
that's correct. Yeah, absolutely.
And then you can combine these two negatives, right? So just make it plus.
Yep.
Perfect.
Yep.
And now at this point, because you're supposed to take another u substitute, right?
Yeah, so now you're gonna subs.
Square root of 1 minus x squared again.
You can't I wouldn't let u be that whole thing, because that'll be too much, but that square root acts like a parenthesis. So think of it that way, it's the stuff inside is probably a good u then. So,
Just whatever, 1 minus x squared.
yeah, exactly.
Okay, that solves my problem, thank you.
You're welcome. And you'll see it like working out, you'll see your x appear and you'll be happy. So. I'm making my limits probably worse than yours are.
I get a little more help.
You sure can.
Because making u that makes this really messy. Because I think I got dx there.
Mm-hmm.
And then, since that's all of u, oh, that would be u.
So you're, yeah.
That would be u over.
So you're combining a couple things. You're doing substitution. So like this move you made here, this is a substitution move to replace that dx. So I would, so let's get rid of that line, the dx equals.
Okay.
Because what we're doing is we're going to uv minus integral v to u. So we're creating a new integral. Do you see what I'm saying?
Yeah, so you're not like solving it with substitution.
Yeah, exactly. You're just rewriting the problem.
Oh, okay, so
Which
in
will
that
turn out
case,
better.
so in that case, it would just be this, and then dx would be dv.
Yes, but the v, so remember, so it's uv, so it's gonna be that times that.
So, okay.
Yeah.
I understand now,
You see?
never mind. I was trying to do it like substitution, I got it.
Yeah, I thought so.
Oh, but every trigger we can
Okay,
do it.
let me take a look and see what's going on here. Okay, so.
I restarted around.
Oh, okay, thank you. Okay, good. Okay. So then you took this and moved down to here.
Yep.
Okay, so yeah, plus. We got the 5 there. So that looks good. So then and just a little tip, this is okay what you did. You could just bring that 5 out in front with the 1/4 and not have to carry it anymore.
But it's okay that you did, completely okay. So, the UB 5. So, we just keep moving on, okay. Yep. Minus this integral, yeah. U, 24 fourths, yeah. So I think you're using your 25 fourths here, which already takes into account the quarter, and then you put the quarter in again. So you
Oh,
got,
I
you
think
got the quarter
I-
and
yeah,
the
I just-
25.
I
Oh,
moved
okay,
those.
gotcha. They're just look like they're in there twice, okay. So, okay, so I see, so 25 fourths, yeah, that looks good, so then that's I. Yes. Mm-hmm. This is looking good. Yeah, so 25 fourths, 20, is that a 9? Yeah, yep, beautiful. 25 fourths. The only thing to keep in mind is you still have this 1/4 out in front of that whole thing. So I'm pretty sure you want the quarters times your 25 fourths first.
Times that
So
first.
25 sixteenths.
Okay.
Does that make sense?
Get rid of that one
Yes,
quarter there. Okay.
exactly. Yep.
Gotcha.
Start working this 1/3. Oh, yeah,
Oh.
yeah, that's cool. Oh, yeah.
Like
you can work
that.
it. Okay, let's take a look. So you let U, how'd you get your DU?
I used the reference sheet to look at
Come around here so we can take a look. So you could either just use this formula.
Okay.
Oh, this is actually, this is the answer to the problem, like kind of right here. So let's go back to your work real quick. Let me show you what's going on. So when you went from U to DU, you should have just taken the derivative. And what you did is you literally went and looked up the antiderivative. Does that make sense?
Yeah.
Yeah.
Yep.
So
Okay.
you've done the problem twice within
Okay.
itself. That's going to make it
Yeah.
really painful,
Okay.
as you saw,
Yeah.
as you can see. Put some guidance up here if you're looking for it. Eventually, I want to come together and talk about those limits, but I want everybody who's working on this one to see what's going on. And so we got your work should pretty much look like that, except for the limits. Hopefully you've all got 0 as one of your limits to make your life less painful than this would be. Yes. Oh, so that's just for there. Yeah, just put it on top. Yeah, exactly. There you go. And you, yeah. It's beautiful. Yeah. Okay, let's take. So this one, are you, okay, cool. You got the right. And it's just not liking what you're putting down there, so let's. Just making sure you got your prints, because I see only 345.
Okay, so parenthetically, that looks okay. Hey, can I take a look at it?
Yes, yeah, got it. Good, good. So that's actually plus 170 because you're integrating up. So that's, I think that's where your problem is. Everything else looks great. I think it's just your signs, your pluses and minuses are off. Yeah, give that shit, just like flip the signs and see what happens. Let's see, so, and you took into account these as well? Okay, so let's double check. This one, so now this one should be negative actually, right? Cause, yes. That one should also be negative, yeah. Yeah, indeed, yeah, hey. Sorry.
Okay, cool. Good. Good. So your U is a little too big. So notice this. So you let U be, and this is good. You like going through the plan, right? Let U be the whole denominator. This isn't quite the derivative because you would have to use the chain rule on it. So if this was U, you would need a negative 2x as well.
Sure. I erased it. But
Oh, okay, I see. Okay, yeah, that looks good. But so the problem here is you have, you see that this isn't canceling, right?
Yeah.
So your U was too big. When you see like a square root, think of that as a parenthesis. So I would let U be the 1 minus x squared, and life's gonna be just the stuff inside.
Cool, yeah, you bet. Yes.
So.
Okay. Let's see what we did. Yes. Yeah, the y squared, I'm sus, so, okay, so let's see here, so you got, so it's kind of like this, the derivative of that tangent of inverse tangent of 4x is actually a chain rule, so let's take a look at that really quick. So when I find d dy of arctan of 4y, so I do the outside first. And so here, the form, this is a chain rule, and the form is kind of this. Here's the outer rule. So you're seeing that, definitely. I see you writing that down. But this thing here, when I do the outside, so first do the outside, so it's 1 plus, leave the inside alone, times the derivative of the inside. So it's actually going to be 4 over 1 plus 16y squared. Does that make sense? Yeah, and that could be, that's definitely a problem. It's a good place to start, at least fixing that up. This is good, thanks for asking though. That's something I wanted to talk about, just like all these are, really. you waiting kind of on that
I don't know.
on that one? I'm not quite sure.
No, I think I finished.
Oh, cool, that looks really good. I think that looks right.
Cool.
Now we just gotta do the limits, right?
Yeah, and I tried to do the limits and it told me I was wrong, so. Super fun.
We'll talk about that. Let's talk about that. Let's.
I don't know like how accurate it wants to answer.
Yeah, I would just keep everything precise. You can get this pretty precise. So let's actually talk about those limits. I want to kind of let's talk about number 2 now, since like I mean it's 10 till 90. It's we got like 20 minutes left. So this was the problem that I gave myself. Yours probably hopefully has a 0 down. I hope everybody's got a 0 as one of those. That'd make life easier. But I wanted to do 2 examples of some things. So I think everybody's on the right road here. We're doing parts. We're letting U be the arc cos. dV is the dx. We find this in a table, or we remember it. We got that. And then I put UV. I'm plugging in the limits. Minus integral V to U, because there's a minus here already. That became a plus. And then I've got it like this. And I just put that X on top. You could have it like this, you know, X dx, but I like to put that X up on top. I know John and I were talking about that just a minute ago. So, any questions up to this point? Because this is where it starts to get hairy. Anybody want to talk about anything here? All right. So now I got to do this integral. Let's talk about that before we talk about arc-trig functions and their values. This is a fraction. When you see square roots, they are parentheses hiding. When you see any root with stuff inside of it, that is a parenthesis hiding. So you're going to let U be the thing inside the root. So I let U be 1 minus x squared. Du is this. Did my substitution. Notice that I actually, remember, when you do substitution with a definite, don't go back. Do the limits. So when x is negative 1/2, since this is the relationship, U will be 1 minus negative 1/2 squared. So that's 1 minus 1/4. That's where the 3/4 came from. And then when x is square root of 3, U is 1 minus square root of 3 squared. So that's 1 minus 3, that's negative 2. It's weird to see that negative limit on top, but it's okay, not a problem. And then that negative 1/2 came out in front, and I got this guy here. And so now I can actually, I'm just gonna go ahead and knock that out so we're done with it, that last part. So let's see here, so we've got, let me just do the scratch here. And then we have this, was it a negative 1/2 out in front? Yeah. Cool. And then there was the blah to blah, what were they? 3/4 to -2. So I'm gonna add 1 to this exponent, I get a 1/2. I divide by my new exponent. So I've got this out in the front, that's real happy. And then I'm gonna let U go from 3/4 to -2. So if you were totally right on with that, those cancel, you're just left with negative U to the 1/2 from 3/4 to -2. And then I can plug in the limits for this piece. That's gonna be negative, son of a gun. Oh no. Oh no. Oh no. I've got division, I've got like a square root of a negative. Damn it. Damn it. I've got to fix that. That can't be. So I'm gonna make this just 0. I think I know what's happening here. So I'm just gonna make that 0. I'm gonna fix my whole problem. Your problem has the 0 in it, so you're all happy.
For us, the zero's on the bottom of the integral, and we have positive 1/2 on the top.
Yeah, that's cool. So it's not exactly your problem,
Close
but
enough.
hella close. So yes, shit, that was like, I didn't see that coming, but now I see why that's, let's see, so the top limit becomes 1. Right, so when x is 0, U is 1 minus 0 squared, so U is just 1. And That's a lot better. That's much better. And then I don't have this nonsense. And so then that just becomes negative 1, square root of 1 is 1, minus negative square root of 3/4. Nobody said this stuff was going to be pretty. So that should actually becomes a plus, right? Because there was a minus. So that's that's this chunk right here. That chunk right there is that number. Then there's this. So the first part, when I plug in the 0, I get 0 times arc cos of 0 minus negative 1/2 arc cos of negative 1/2. And this is the stuff I wanted to talk about right here. Getting those trig values, those arc trig values, which is weird. You could do it on a calculator, but it's nicer to do it precisely. So these are graphs that wouldn't hurt to know. They're in that table, that big packet of information I gave you with your integrals and derivatives on it. These are great graphs. These are the arc sine and arc cos functions. They're weird functions because they just live in little boxes, unlike polynomials that are all through the plane. These just live in these tiny little boxes. That's why I put these solid dots. Like, that's where they end and start. So I want to find the arc cosine of 0. Well, the arc cosine of 0, let's talk about this. The arc cosine of 0, well, first off, let's just talk about arc cosine of x. This is an angle. This represents the angle whose cosine is x that lives between 0 and pi. So what is 0 and pi? That's the top half of the plane. So here's 0, here's pi, that's like 180 degrees. This is 0 degrees, this is rads, this is rads. So our cosine is the angle whose cosine is x that lives in this top half of the plane. Arc sine lives between negative pi over 2 and pi over 2. So arc sine of x is the angle whose sine is x but lives in here, between negative 90 degrees and positive 90 degrees, or negative pi over 2 and pi over 2. So arc sine lives here, arc cos lives here. So that makes life a lot easier now. So to that time, well, luckily I've got 0 times that, as you will too, and you don't have to worry about it because it's 0 times something. But what is the arc cosine of 0? Check it out, I can look right here. It's pi over 2. Arc cos of 0 is pi over 2. So this is 0 times pi over 2. And then plus 1/2 arc cos of negative 1/2. I've got to figure out the angle whose cosine is negative 1/2 that lives in the top plane. Now, that can be pretty tricky. Like Sophie's got the unit circle memorized. She was talking to me about that the first day of class. How many folks know this unit circle? Kind of got it, like, yeah. So I think that can help you. I think that can definitely help you. Let me show you how I would do this. I would just build this shit up. So I want to find the angle who's in this top half plane, whose cosine is negative 1/2. It's going to be a special angle, and I know 2 triangles. I know this triangle here, this is my 45, 45. So this is like my little mini trig lecture, like part 1. I'll be doing more of this. This special triangle goes like this, and that's just Pythagorean theorem. A squared plus b squared is c squared. These angles are the same, so the sides opposite them are the same. Here is a 30-60 triangle. Here's the 30, here's the 60, here's the 90. This triangle has sides 1, square root of 3, 2. These are great pictures to know just for your whole academic career since you're all doing science stuff. These are great things to know. So if I put one of these, for example, up here, if I wanted to know what is the cosine of pi over 3? Well, I would draw pi over 3 up here and go from, okay, here's pi over 3. And then I would put these sides in the appropriate situations, right? So this is gonna be 1 here, this is gonna be square root of 3 here, and the hypotenuse is always 2. So the cosine of pi over 3 you know this? We know SOHCAHTOA? Yeah, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, cosine of pi over 3 is adjacent over hypotenuse 1/2. So the cosine of root of pi thirds is 1/2. Now I need to find the cosine I need to find the angle whose cosine is -1/2. Notice that if I just take this triangle, put it over here, I get a -1, the 2, and the square root of 3. So this angle here, this triangle, you look at the reference angle, look at adjacent over hypotenuse, -1/2. So this angle here, this little pocket, that's pi over 3. So I want this whole angle here. This is you always measure your angles from the positive x-axis. Since this whole thing is a pi, this is 2/3 of a pi. So that answer right there is the cosine of -1/2 is 2 pi over 3. So this whole damn problem is this plus this, and it is atrocious looking. So our final answer for my problem is going to be, notice how the 2's cancel, pi thirds -1 plus square root of 3/4. Crazy. Happy to help you with all of that. That was pretty fast.
What would it be if it was a positive 1/2? How can you tell that?
If it was, for some reason, what an interesting question. Yes, if it was positive 1/2, what angle has a cosine of positive 1/2 is what you're asking? So like if this was this, Sophie,
Yeah.
like that?
Do you just not invert the triangle?
Yeah, so let's take a look. So the cosine, I also do this. All trig functions are positive here, only sine is positive here. So ASTC, this is how I learned this shit back in the day when the dinosaurs roamed the land and so forth. But so this thing here, if cosine has to be up here and it has to be negative, it has to be in this quadrant. If I want the relationship, so I want the angle whose cosine is 1/2, that's adjacent over hypotenuse. So I have an adjacent side of 1, that's the -1, and the hypotenuse is 2. So once I've got that, now I see that this must be pi over 3 right here. Oh wait, I'm not answering your question. It's positive 1/2, right? I
You
got a
wanna
little.
do it in the tangent quadrant, right? 'Cause
Yes.
both values positive.
Yes, so like here, yeah, in this quadrant, in the first quadrant. So cosine of 1/2, so you have adjacent, hypotenuse. So this is the square root of 3 here. So this must be pi thirds. So the answer is pi over 3. So everybody should have pi over 3 in there. Not like that makes the problem easy. Still plenty of stuff to do. Yeah, yeah. Yeah, is it working out?
No.
Okay, let's
because
take a look.
When I plug in 1/2 here,
Okay.
I don't know what it does look like.
Yeah, oh, well, you still, remember you got the -7 up front?
Oh, yep. That
There you go, try that, you
So-
can just pop it in here, like, put -7 times the whole thing, and let's just see if that's where the whole thing is. I didn't tell, but that's definitely something we need to have in.
Does that have any bearing? Can you just plug the -7 to each of your values at the end once you've like done the integral, or does it
Yeah.
have to be before?
No, it doesn't have to be, not at all. So you could just work it out. So like you could just, yeah, take this and plug those values in. So let's check. So is that what you're doing actually? It looks, yeah, that is what you're doing. That's great. You just worked it all out. You got this beautiful form. And so then you put in your limits where 0 and 1/2, so you put in the 1/2.
And then the 0 each
Yeah.
goes so close.
That's correct, so I did not lie. So that's pi over 6, okay. And then we put 0 and that dies. And then we've got this chunk here, so we put in 1. Oh wait, excuse me, put in 1/2 and that got us the square root of 3/4. Put in 0 and we get a 1. And I don't see why that's not working.
Well, because you have to put the 7 in.
Yeah, but still, but you did here, right? And
Do you think it wants it? Oh, well, could it be that I have to do pi over 6? Maybe it doesn't like.
it shouldn't, WebWorks should be smarter than that, a lot
Should
smarter.
be.
It should be, and it is, I have faith in it. What the hell? Okay, let's go slower, let me see. So let's actually, can you pop that table back up?
Yeah.
I just wanna look and make sure we got our, yeah, we can check if we got our formula right,
I think, because I literally took a straight.
You took it straight from
Like,
here.
I took a screenshot of it
Okay,
and put it over.
cool.
Wait, that one. That's, I need to,
we're really adept at working with this.
this one. Right, so,
Is this an iPad?
yeah.
Yeah, I need to get a lesson from you on what you're doing, because you're like really doing great manipulation.
Actually,
So actually, but down here, I think they actually have the, kind of the answer to our problem down in here. So there should be like here we go, so, see, you got, yeah, so it's gonna be u cosine inverse of u minus. Did you have a minus in there? I don't think so, and that might
I
be the
think
problem.
the minus is canceled. Because there was a negative 1/2 times it. Oh, it was like the 1/2 there,
Yeah.
and then so that's a minus, so then when you subtract it from there, it becomes positive.
Yeah, so let's be careful though, because there was a minus and a minus, so that actually was a plus to begin
Right.
with,
Oh, to begin with.
right?
So
Those
it
two
should be
were plus, so it should be
negative
negative now, that's
Okay.
it.
So that whole thing was just over.
Yeah,
So then I would just need to
absolutely.
change that to minus that, and then
Yes.
plus that.
Yeah, that should work.
Minus the first. Okay,
Yeah.
it was all over a negative.
Nice.
Okay.
What was that formula we were just looking at, so I can tell everyone, just so they can check themselves?
Well, that was the one that
yeah,
I used
no,
for
the-
cosine of negative 1.
The one I was just looking at,
There.
sorry, thank you, I really appreciate your help.
Yeah, no problem. Is it this one?
Yeah, it was. Alright, so formula 88. So formula 88 in that table will help you. You can probably, if like you're struggling with this, formula 88 can help you knock this out a lot faster. Formula 88 literally gives you the answer almost. I'll never ask you to do something like that.
no stress about that. My exams are pretty basic. I make you do all the hard stuff, like not on the exam. That's when the suffering comes in. Yes.
I just restarted on it. Would you be able to help me work through it?
Sure, sure.
So,
Okay.
I wrote that much
So,
down.
okay, cool. So use. Okay, gotcha, yeah. Beautiful, and then the negative, okay, so that looks good. And then DV, okay, cool, so then what's UV then?
So it'd be -9.
And so I've got a tip, actually, I think it'll help keep you a lot saner. Let's just do this at the end. So just kind of leave it out, because it's sometimes you'll get it like copied over again, you know what I mean? So let's keep the 9 out, and in the end, we'll just multiply everything we have by 9.
Oh, by 9.
By
Okay.
-9, so much better that
So
way,
it's be
yeah.
-1 right here.
Yeah, exactly.
So I guess I'll just do that. Oh wait.
I yelled 6 so wait, what do we got?
Yeah,
Yeah, okay, sorry, but I think
No,
this will
you're-
be less suffering for you in the
Yeah.
end.
So Earth plus
Okay, so one thing here, so the V doesn't have the DX type. The only stuff that scratch that out, because
that's
that'll,
right.
yeah,
That's
gotcha.
yes. And then minus the so it'd be oh yeah, it's easy. So you got X and over what would be negative X over minus X squared. And then I guess I'll just this one. U substitution.
And that's a use of, yeah, and I would just make it a plus, so like I would just rewrite it, because you got a minus, make it a plus, so there's just one less thing to worry
Oh,
about.
so just do this?
Yeah, yeah.
Okay, cool, so now I'll get, wait.
Thank you, Dr.
Oh, thank you. See you on Wednesday. Let's kill this off.